Today we're going to be learning multiplication properties of exponents. So if you look at your notes at the top, the product of two powers with the same base. Remember that the base is the large number. So in this example, the 2 is the base. So when you have the same base and that base is raised to the sum of the exponents, here is what that means. If you have 2 to the 5th power times 2 to the 6th power, what you really have is 2 multiplied times itself 5 times and 2 multiplied times itself 6 times. So altogether, you have 2 being multiplied times itself 11 times, 2 to the 11th power. So notice what we did with the exponents. We had an exponent of 5 and an exponent of 6, and we got the sum. We added them together. Very simple property. Next example. Here in this example, you'll see that we have two different bases. We have a base of A and we have a base of B. So if we use the commutative property, we can see that we have A multiplied times itself 4 times. Blue marker here. Here's A multiplied times itself 4 times. Here's A multiplied times itself 2 times. And here's B multiplied times itself 5 times. I just grouped the A's together. Well, how many A's are there altogether? There are 6. All we had to do was add the 4 plus the 2 to get 6. And then B stood alone. So our final answer was A to the 6th power and B to the 5th power. In the next example, if you look at this, I'm going to show you a couple of different ways. The first way, on top, we have y squared, so it's y times y. And then we have y to the first. Remember, if there is no exponent, there is an invisible 1, so y to the first. In our previous lesson, remember that when we have a negative exponent, we have to move it downstairs. So we actually have 4 y's moved down to the denominator. These 3 y's cancel out 3 y's, and you can see that all we have left is 1 y on the bottom. Now, if we just use the property that we just learned with the same base, this also means that we take the exponents and we find the sum of them. So we have 2 plus 1 minus 4. I just took the exponents, 2 plus 1 minus 4. That is y to the negative first power. And then to simplify that, we move it downstairs. So you see that we get in both examples, we get the same answer. And the 1 obviously can be invisible. This works with scientific notation as well. So you can tell with the highlighting up here that we're going to use the commutative property to regroup. So we can multiply the 2 or the 4 and a half or 4 and 5/10 times the 2. We can group them together, multiply them. Of course, we know that 4 and a half times 2 is 9. And then with our power of 10, we have 10 to the 3rd times 10 to the 5th. I'm just using the commutative property here. We just learned that when we have the same base, that we add the exponents. So that would simply be times 10 to the 8th power, because we did 3 plus 5. It can become a little more tricky in an example like this. I've highlighted again to show you how we're going to group with a commutative property. We have 6 times 7, which is 42. And then we have 10 to the negative 5th times 10 to the negative 2nd. If we add a negative 5 and a negative 2, we get a negative 7. We've talked about moving negative exponents downstairs to get rid of them, but in scientific notation, it's okay to have a negative exponent. It just represents that the number is going to be a decimal. When we multiply this, we get 42. And then we add the exponents, and we get 10 to the negative 7th power. But if you notice right here, 42 is not written in scientific notation because the number is not in between 1 and 10. Right now, the decimal is at the end, and we have to move it between the 4 and the 2. Moving it one place over adds 1 to our exponent. So our final answer would be 4 and 2/10 times 10 to the negative sixth power to get it in actual scientific notation. Light from the sun travels about 1 and 86 hundredths times 10 to the fifth power miles per second. Takes about 500 seconds for the light to reach the Earth. Find the approximate distance from the sun to the Earth. Write your answer in scientific notation. Here we can see that the first is written in scientific notation, but 500 is not. So the first thing we're going to do is convert 500 to scientific notation. Right now the decimal is at the end, so we have to move it over 2 places. So we have 5 times 10 to the second power. Now we can use our commutative property. And we can multiply the 5 times the 1 and 86 hundredths. And then we have 10 to the fifth power times 10 to the second power, so we're going to add those. When we do that, we get, oops, I typed up too much, 9 and 3/10 times 10 to the seventh power. I'm going to go one step farther. Now we have something that we refer to as power of powers. It is an exponent being raised to an exponent. The power raised to another power, think of an exponent, equals that base raised to the product of the exponents. Here's what that means. When you have 2 to the fifth power raised to the third power, you have an exponent raised to an exponent. What you actually have is 2 to the fifth power 3 times. If you look to see how many 2's you have right there, you have 15. So what we did is we took the exponents and we found the product, or we multiplied them. So when you have an exponent raised to an exponent, you actually multiply. If we apply that same property to this, 3 to the sixth power raised to the 0 power, we would multiply 6 times 0. And we know that 6 times 0 is 0. And we have also learned that anything raised to the 0 power is 1. In this next example, in the first x, the base of x, we have a power raised to a power. So that is x to the second power raised to the negative fourth power. So we have learned that we have to multiply those. That would give us next x to the negative 8th power. Now we have the multiplication property. We have x to the negative 8th power times x to the 5th power, where we add the exponents. That would be x to the negative 3rd power. And of course, we have to move that downstairs. So our final answer would be 1 divided by x cubed, or x to the 3rd power. Now, if inside the parentheses you have more than one base, here we have in parentheses negative 3, which is a base, and x, which is a base. We have to apply the exponent to both of these. We have to distribute it to both. So what you actually have is negative 3 squared and x squared. Now we can evaluate that, and we know that negative 3 squared is the same thing as negative 3 times negative 3, which is a positive 9, and then we have x squared. Now that is going to be different than the following example, where we have the negative outside of the parentheses. Remember that parentheses makes all the difference. So in this example, we have the opposite of 3 squared and x squared. So we have 3 squared, which is 9, and then we have x squared, but we want the opposite of that. So in this example, the answer is going to be negative. So be careful about your parentheses and where the negative signs are located. Okay, in this example, we have 2 bases. We have a base of x, and we have a base of y. So we are going to distribute this to both. So in the first one, you have x to the negative 2 power raised to the 3rd power, and you have y to the 0 power raised to the 3rd power. If we apply our property of power being raised to a power, so we multiply the exponents, we would have x to the negative 6 power, and we would have y to the 0 power. Now, when simplifying this, we have learned that when we have a negative exponent, to get rid of the negative exponent, we move it upstairs or downstairs. So we're going to move this down to the denominator. X to the sixth power is now downstairs. Got rid of the negative exponent. And we have also learned that anything to the 0 power is 1. So that just leaves a 1 on top. So your final answer is 1 divided by x to the 6th power. Here's some examples where they get a little longer, but still the same properties. In the first set of parentheses, we have two bases. We have 4 and x. Each one of them is squared, so we have to apply that to both of them. I don't know why I did that. And I do not know how to get rid of it. We will try this again and see if we can get rid of that little. There we go. Okay, so what we have here is 4 squared and x squared. Well, while you're doing this, you can go ahead and mentally do the 4 squared. 4 times 4 is 16. So in that first set of parentheses, we have 16x squared. In the next set of parentheses, we have three bases. We have 2, we have x, we have y, all being raised to the third power. We have to distribute to each one. So first we have 2 cubed, which is 8, x cubed, y squared raised to the third. So we multiply again here, and that would be y to the sixth power. Now you can look at this, and with your commutative property, you can group together the common bases. First, we can actually multiply 16 times 8. Then we have x squared times x cubed that you can group together, and you have y to the sixth power. And when you simplify all of that, a lot of writing on there, you are going to have 128 because 16 times 8 is 128. X cubed times x squared is x to the fifth power, and then you have y to the sixth power. All right, in this example, you have a set of parentheses to start out with, so we distribute the squared to both of these. We know that 3 squared is 9. X raised to the second power is just x squared. The next part is not in parentheses, so we just have 2x to the negative third power. Now with the distributive property, we can group together our coefficients, so we have 9 times 2. And then we can group together our bases of x, which is x squared times x to the negative third power. 9 times 2 is 18. We know to add these exponents, so that'd be x to the negative first power, which has to be moved downstairs. So when it moves downstairs, we have 18 divided by x. In the first set of parentheses, we do not have an exponent here, so we just have negative 4x. In the second set of parentheses, we have to apply the 3 exponent to each, so we have 2 cubed, which is 8, and we have y squared raised to the third, which would be y to the sixth. Now with our commutative property, we can group together the negative 4 and the 8. And the x's and the y's don't have anything that they share, so it's just negative 32. I'm trying to figure out why I have an x squared right there. I think that's a typographical error, and it is. Y to the sixth power. All right, on your assignment that you are doing today, there are 2 pages. On the first side, do the first column, the first 12 problems, and the next 4 problems. So there's 16 on the front side. And that is punchline 11.9. On the back side, which is punchline 11.10, you are assigned the first column. Everything else is bonus.